Jai Hind to all. Myself, Dr. Parneet Kaur, Assistant Professor in AKGEC Engineering College, IT Department. Today, I'm going to start with my new series of machine learning on decision tree. And in the previous series, we have seen the concept learning techniques as well as the algorithm related to them. But in this topic, we're going to discuss about the decision tree concept in detail. So the agenda of this presentation is, we will going to discuss about the decision tree explanation. Then we will going to see the demo of decision tree with an example. Then the concept of information gain and Guinea Index with some more demo examples. So let's proceed. So let's first talk about and see what actually is a decision tree. If we check that decision tree is actually an algorithm which falls under the category of supervised learning, where we require some sort of supervision in order to perform some learning task, which cannot be performed independently by the user. They can be used to solve both regression as well as classification problems. So we categorize our problems into two domains. One is regression, another is classification. And they are used for both type of categories. Decision tree uses the tree representation to solve the problem in which each leaf node corresponds to a class label and attributes are represented on the internal nodes of the tree. So if we look at the decision tree, it is like a simple concept tree where we have a root node, and we have a leaf node. So it says that in order to solve the problem in which each leaf node corresponds to a class label. So wherever we have these leaf nodes, they represent certain class labels. And the attributes are represented on the internal nodes. So whatever value is there, that are inserted inside the internal nodes of the tree. So here we can see an example. We have a data set which comprises of certain peoples and the inputs are given in form of age, gender and occupation. Now if we want to form a decision tree related to it and we have a problem, the problem or the case scenario is that does the person likes computer games or not? This is the problem which we want to solve using a decision tree algorithm. So how we will going to solve it? We will check about the first attribute, that is age, and we will categorize the age in less than 15 years or greater than 15 years. Now suppose the candidates which falls under less than 15 years are further divided into two categories, that is male and female. So if we have male category, then we can distribute that. Is the candidate is male or female? If it is male, then we say the attribute comes under the category of yes, otherwise it comes under the category of no. Similarly, the remaining set of database goes on the other side of the decision tree. Further, we need to classify it that this age is greater than 15 or less than 30 years. Then further we can form a decision tree related to it. But now we want to find that does the person likes computer games or not. So here we have a person from this decision tree. This is a male candidate and its prediction scores comes out to be higher, that is +2, whereas female's prediction score comes out to be +0.1 only. And since all these are greater than 15 years of age, so their prediction score is -1. Okay, so here we can see that the decision tree is formed with the help of certain values. The weightage is given to them in terms of certain values, and according to that we categorize the male and female candidate into different leaf nodes. If we look at the further explanation of decision tree, it is actually the beginning. We consider the whole training set as a root. So first of all, the very first step says that we have to take the whole data set in the form of a root. The feature values are preferred to be categorical. Whatever attributes, whatever features we give them, they are under the form of certain categories. That's why they are known as categorical. And if the values are continuous, then they are discretized prior to building the model. On the basis of attribute values, records are distributed recursively. So this is one of the important points, that the records are distributed recursively. We use statistical methods for ordering attributes as roots or the internal nodes. Now, as I have already told you that there is a certain concept in terms of prediction values, +1, -1, +2, -2, they comes under statistical model or methods. So whatever values we give to the decision tree and whatever values we put in certain leaf nodes, They are on the basis of certain stats values. Okay. So again, we will see this decision tree here. We have tree 1 and tree 2. Now here in this first category, we have already distributed the tree in terms of the case study or case scenario, that whether the person plays video games or not. And for that, we have divided the tree into two different parts. One is those persons which are having age greater than 15 years and one are those persons which are having age less than 15 years. Those which falls under the age of less than 15 years. Further, we can classify them in terms of whether they are male candidates or female candidates. Then we have further classified our tree into male and female, and then we have certain prediction values related to them. Similarly, those which do not fall under the age of less than 15 years, their prediction value is very less, that is -1. Now, what we can see here in the above image, that decision tree works on the sum of product basis, that is SOP. First of all, we have to calculate the product and then we combine them and form a sum of that, from which it is also known as a disjunctive normal form. So in the above image, we are predicting the use of computer in the daily life of the people. So whatever we are doing, we are predicting the daily life of the people. So here also you can see in this pic that we have the candidates which are having values plus 0.9 and the remaining are -0.9. We add those values with each other, that is sum of product, and similarly sum of product is calculated here also. Now in decision tree, there are two major challenges to identify the attribute for the root node. This process is also known as attribute selection. So we have two popular attribute selection measures. One is called as the information gain, another is called as the Guinea Index. If we go through what actually this information gain and Guinea Index is, let's see them in detail. When we use a node in decision tree to partition the training instance into a smaller subsets, the entropy changes, because whenever we take a decision tree and we partition that training data set into small parts, then with each stage the entropy gets changed. So information gain is measured of this change in entropy. So whenever this entropy gets changed, that value is known as information gain. Now suppose we have a very big huge set, that is capital S, and we have an A as an attribute. So SV is the subset of this big set taken from the SV is taken from this capital S. So S with A is actually an attribute with having certain value small v, and it is the set of all possible values of A. So here we have a gain with a big huge set, that is A, S, and we have certain values related to it. So the entropy value is calculated by taking the we have a difference with this. We have VC of V values of A, and we have taken SV, that is the subset over a full superset, dot, that is the product entropy of S of V. If we see further examples related to it, then the definition will be very much clear to us. Now entropy is the measure of uncertainty of a random variable. It characterizes the impurity of an arbitrary collection of examples. The higher the entropy, more the information content. Suppose we have S as a superset. It is a set of instances. A is an attribute. SV is again the subset. Now if we calculate the entropy for it, we have this value, entropy of S. Here we have a gain of S comma A, we have equal to entropy of S minus the summation of V of CV values A, then we have a modulus and we have a product of entropy of S of B. Now suppose, let's take an example. We have a set of x values, we have certain a's, we have certain b's. If we take total instances, that is total number of values in this set are 8. The number of b values are 5, number of a values are 3. Now, if we take entropy, this is the equation for entropy, h of x equals to minus 3 by 8. This, by putting the values in this formula, we get the entropy of h of x, this whole set. Now, what is 3? 3 is a, number of small a's, and 8 is the capital S, that is the whole set. Then we take a log of 3 by 8 also with it. We take log 3 by 8. Then we take sum. Then remaining values of number of b's in this are 5 by 8. We take log of 5 by 8. This is the whole equation which we have for calculating the entropy value. And finally, the output which we get is, that is 0.954. This is the value of the entropy which we get for this whole superset. Now, let's take another demo for a decision tree. Suppose we have a data set in this form. We have certain features related to it, and in these features we have certain classes also. Let's see that suppose we have 3 features, x, y and z, and this is the class category. We have 2 types of classes. One class is this, another class is this. We have these 3 features, x, y and z, and their attributes are binary form, 0, 1. In x, the number of ones are 3 and 0 is 1. Similarly, in case of y category, number of ones are 2, number of zeros are 2. In z also, number of ones are 2, number of zeros are 2. So, if we want to calculate the information gain for this, how we will going to do it? We take first of all a whole superset, that is S. Then we have 2 values, that is this x we take. Now we know that we have 3 types of attributes. One is x, another is y, and the third one is z. So first of all, we will take the first attribute, that is x attribute. And for x, we have 2 categories, that is binary values. One is 1, another is 0. Now for 1, first of all, we take, this is our first parent node. The parent node R is 1. We take its 2 child, this child and this child. So we take the first child. In the first child, we have 1 by 3. 3 is the whole set and number of ones. Okay. And that is number of 1 is 1. That is 1, and we take log 2 of 1 by 3. Similarly, if we take this value, that is minus with 2 by 3 log of 2 by 3. If you look at the table, you can see here in x, we have 1, 1, 1. This 1 comes under the class, 2 ones comes under the class, first this class, same class for these ones. But this one falls under another class and we don't take 0 in this case right now. 0 is another child for it. So we can say that 1 falls under this, and 0 falls under this class. Okay. So for 2 class, we have only 1s, and this is for 1, 1, and this is for 1, 1. Okay. This 1, 1. This is first class. So 1 by 3. 3 is the total set. So 1 by 3. Then we have this 1, this 1. These are these are 2 ones, separate 2 ones. So they are 2 by 3. So this is the entropy for child 1. When we calculate its value, we get entropy for child 1 is 0.9184. And if we move to the x equal to 0 category, then we cannot calculate, because 0 we have in this 0 category, it only falls under this. So its value comes out to be that is 0 if we calculate its entropy. Okay. So You can see here because it's only 1. So 1 by 1 log of 2, 1 by 1, we get the value as 0 only. Now similarly, for the y attribute and for the z attribute, we calculate the entropy for child 0, child 1 and child 2. This is child 1, 1. This is child 2, that is 0. So for both the entropy is coming out to be 0. When we put the value in the gain, gain's formula is 1 minus 1 by 2 of 0, that is the child 1 entropy and child 2 entropy. So the value comes out to be 1. Similarly for z also, we have child 1 entropy and child 2 entropy is coming as 1 and 1. We will calculate its gain, that is information gain. We get the value this. As in this case also, when we calculate the gain, 1 minus 3 by 4. This is total values 1, 2, 3, 4. So we have total value as 4. And the first category comprise of 3, another category comprise of only 1. So the gain comes out to be 0.3112. Okay. When we put the value here, we get the gain like this. So in case of y and z attributes also, the information gain is calculated in this manner. First of all, we have to calculate the entropy and then we calculate the gain. Now from this we can say that from the above images, we can see that the information gain is maximum when we make a split on feature y. So for the root node, the best suited feature is y. So in this manner, we can calculate that which value we will going to take in the root node. As you can see in this diagram, after calculating the information gain and entropy, for the x value, we have information gain coming out to be 0.3112. And if we move ahead, the information gain is for y and z is very high, that is 1. So those you can say leaf nodes which information gain is high, they are moved to the root node. That is how the decision is taken in the decision tree. So those values whose information gain is coming high, they are taken at the root node. And then further they are splitted. Like we can see here that in case of y, we are having value as coming out to be 1. So we will consider it for further categories. So that is how information gain is calculated. Now we look into the another form that is called as Guinea Index. So Guinea Index is again a type of a matrix which is used to measure often randomly chosen element which are incorrectly identified. Suppose we have a big database and we have certain elements which are incorrectly identified. So in order to choose or measure some elements randomly from the whole database, then the method is known as Guinea Index, and those whose Guinea Index is lower, those values are preferred. Okay, those are taken at the root node and so on, and further whose Guinea Index is very high, they are taken at the bottom of the tree. So the formula for Guinea Index is we have equal to 1 minus the summation of number of elements, and we calculate its summation, the sum of the values of Guinea Index, and we take the square of the values and we take the sum of them. So we look here, we have a very huge data set. In this data set, we have 16 values and we have certain features. So there are 4 features in this A, B, C, D, and the final output which coming out to be is we have how many number of positive features are there, how many number of negative features are there. So for this whole data set, we have equal number of positive, that is 8, and equal number of negatives, that is 8. Okay, and for other features like A, B, C, D, we have different values. Okay. So let's take in the data set above, there are 5 attributes. That is E is the predicting feature which contains 2, that is 2 types of positive and negative classes. We have equal proportion of these classes. In Guinea Index, we have to choose some random values to categorize each attribute. So let's take for A. First of all, we take A value. For A, we will take those values which are greater than 5 or less than equal to 5. Now, for the A value which is greater than equal to 5 and its class is positive, so number of 5s are coming out to be 5 and the total values are 12. We can see here in our example that how many positive values. For the positive values, we can see here that the total values, those are the 5's values, greater than equal to 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total values are 12, which are greater than equal to 5. Okay. And those are 12 values. And total number of positive classes are, if we look at the total number of positive classes for this category, whose values are greater than equal to 5, we have 1, 2, 3, 4 and 5. So that's why we have taken 5 by 12. So 12 means total number of values which are greater than equal to 5, and 5 is total number of positive values which are greater than 5. Okay. So that's why we have taken 5 by 12. In the similar manner, we will take the values which are comes under the category of or the class of negative, which are greater than equal to 5. So total number of classes which are greater than equal to 5 are 12, and those classes which falls under negative and greater than equal to 5 are 7. So that's why we have taken 7 by 12. Now we will calculate its Guinea index, that is 5 and 7. This 5 and 7. 5 and 7. The Guinea index is calculated by putting the values in the formula. We have the formula 1 minus, we know that summation of j of p square j. So these are the positive number of classes. We take the square of them. That is the formula. So 5 by 12 square plus 7 by 12 square. That is the summation. And j is the number of values. We have two sets. So 5 by 12 square plus 7 by 12 square. We subtract it with 1. We get the value as 0.4860. Let's move to the another category of class A, that is those values which are less than 5. If we look at the category which are less than 5, total values are 4, which are less than 5. And total number of values which falls under the positive case class with less than 5 value is 3. Similarly, for negative class also we have 1 by 4. Now, the Guinea index is 3, 1 by taking this value and this value 3 and 1. We put the whole value in this formula, that is 3 by 4 square plus 1 by 4 square, and we get the value as 0.375. So by adding these two weights, this weight and this weight, this is 4, 8, 6, we multiply it with the total set. Total set is having 16 values and total number of positive cases or less than, they are 12. Similarly, for negative also we have this 4 by 16. So the final Guinea index which we get is 0.45825. Okay. Now with the same manner, we will going to calculate the Guinea index for variable B, C, D also. And you can see here, we have calculated the Guinea index for B also. We get the value of 0.4460. For C also and for D also. Okay. For every C and D also we have calculated the Guinea index. Now, in this we can see here that the Guinea index for A is 0.45825, for B is this, for C is this, and for D is this. Now, the smaller value of Guinea index is with this category, that is C. So, C Guinea index is less than D, then D's Guinea index is less than B, and B Guinea index is less than A. So, highest Guinea index comes out for A and very less for C. It means we will going to consider C at the root node. Okay. And we will take the decision according to that in our decision tree. So, after deciding that which value comes at the root node, that is C, we put C at the top. Then we further categorize the C into two classes. Its classes are less than 4.2 and greater than equal to 4.2. Under less than 4.2, we have D now. D has two categories, less than 1.4, greater than 1.4. Then under less than 1.4, we have B, which has less than 3.0, greater than 3.0. And then further we have A also. In this manner, we will form the decision tree. This, all positives are taken this side. So, in this manner, we form our decision tree. So, this is the two techniques. One is called as the Guinea Index, another is called as the information gain, with the help of which the decision tree is formed. So, they are the two main, you can say, the building blocks of decision tree. So, there are further categories also for decision tree. One is iterative dichotomizer tree, ID3. Another is C4.5. And the last one is classification and regression tree, also known as CART. If you look at the iterative dichotomizer tree, this algorithm uses information gain to decide which attribute is to be used. So, basically in this ID3, we make use of the concept of information gain, which we have already seen. If we talk about C4.5, this algorithm is the successor of ID3 and it uses either information gain or gain ratio to decide upon the classifying attribute. Okay. And ID3 algorithm, as it can handle both continuous and missing attribute values. For the last category, we have classification and regression tree, also known as CART. It is a dynamic learning algorithm which can produce a regression tree as well as a classification tree depending upon the dependent variables. So, the last tree basically comprises of regression tree, which uses the concept of classification and for the dependent variables. So, these are the further trees for your study. You can deeply study them. But the common tree which is being used is decision tree. And from these decision tree, these advanced version trees are formed. So, thank you all.